everybody, and welcome to another episode in Introduction to Scripting for Roblox. In this episode, we'll be covering numbers, specifically integers and doubles, also known as floats. If you want to get specific, doubles and floats are actually nothing alike. This is not supposed to be a perfectly specific computer science tutorial series. It's just supposed to really teach Roblox scripting. So I'm going to try to hold myself back from being perfectly technical, and we're just going to use the term doubles. Now, the difference between numbers and integers and doubles isn't really all that big. Now, most people consider a number to be a number. A number is 1 through 9, or 0 through 9, has those digits. Sometimes it can have a decimal place or a comma, depending on the size and actual value of the number. Well, computers are sort of the same, except they split up what we call whole numbers and decimal or fractional numbers into two separate types of numbers. Now, the first type is whole numbers, and whole numbers are basically anything that doesn't have a decimal, so from 0 to like a Google. That's what we call a whole number. However, in scripting, or basically computers in general, we call that an integer. An integer is basically any number that is a whole number, and it can be a negative number, it can be 0, it can be a positive number. It's just really a number. And that number has to be a whole number. It can't have a decimal place. Now, the thing is, though, decimal places do exist, and they exist also in Roblox. So what we call those in the computer scripting world, as I accidentally pressed the right click button, is we call those doubles or floating point numbers. Either of the two terms is technically correct. However, when we say double, it's typically the more common term in many scripting languages, and it's what I typically say. So I'm going to call them doubles. However, you might hear me say floating point, floats, or decimals, but typically I will be calling them doubles. So just keep that in mind as we continue. Now, a double, as I said, is basically any number that can have a decimal place, or that has a decimal place value. Now, the reason that computers split integers and decimal place values up is because computers store things all in ones and zeros. And in order to make ones and zeros turn into numbers we understand, like 3s and 4s, these ones and zeros are actually combined and multiply basically against each other. Well, they add together, but they're also exponential values of 2. Now, I'm not going to get into the really nitty-gritty details of what that really means, but I think it's safe to say that if you just understand that an integer takes up less space than a double, meaning it's less hardware intensive, takes up less space on your hard drive or in your RAM or memory, because it takes up fewer ones and zeros than a double, then you'll understand why we use integers whenever possible. Remember, there are 3 things, and I don't know if I've mentioned this third one yet as of this point, but I am going to mention it now. There are 3 things that are really important to scripting and basically programming in general. One is readability. Readability is arguably more important than functionality. And the reason it's more important than functionality is because if you can have a readable set of code, if it works, but then later on you want to upgrade it, and I'm talking later on like maybe 3 months later or even like 3 years later, you probably aren't going to remember your code all that great. But if you can read through it and understand it easily, then that's always helpful. Or if it isn't functional and it doesn't work, you can have somebody who knows more than you or may just know more than you in a certain subject area of what you're trying to make. And they can read through your code much easier and help you fix it. The second thing is functionality. The second most important thing is functionality. Now, readability and functionality are arguably both the most important thing, but I say readability is more important because code can always be made functional, but it's very hard to make ugly functional code functional and readable without having a lot of work put into it. But readable code that isn't functional is much easier to make functional and still readable. So functionality is the next important thing. And the third is efficiency. Efficiency is making sure our code runs as fast as it can, takes up as little memory or data as it can, so that people's computers or phones or whatever aren't slowed down by it. So the faster it goes, the better. So efficiency is number 3 most important thing when making a game, a program, a website, anything on a computer. Efficiency is a very, very, very important thing, and that's why we want to separate numbers that are integers and numbers that are doubles from each other, so that we can make things more efficient. By any time we know that it's never going to have a decimal value, or it never has to have a decimal value, we're going to store it in an integer because it's better that way for the computer to run fast. That's efficiency. Again, readability, most important. Functionality, second, very close second. And then close third, not as close as readability and functionality, but very close third place is efficiency. So let's not forget that. Now, next up I want to talk about the order of operations. But first we need to make a script. So service script service script. Blow up this text here. And I'm going to show you guys just a real quick iteration. Local integer equals 1. Local double equals 1.0. Okay, now if this actually makes it easier, 1.1. And the reason I'm doing 1.1 there for making it easier is because a double, technically, if you want to think about it and remember why it's called a double, and I'm not sure if this is the exact reason why, but it helps me understand it, so hopefully there's somebody else out there that can help. But a double means, in my mind, that there's a double number connected by a dot. One number is obviously the bigger and it's on the left, and the other number is more specific, more exact, and it's on the right. And they're both equal in value to each other, equal in importance typically, but they're two numbers that are connected together by the dot. They're double numbers together, if that makes sense. Hopefully it does. The next thing I want to talk about is using these numbers for math and order of operations. Order of operations, I'm sure all of you who are watching this video, if you've been in the 3rd grade yet, you have covered order of operations. And order of operations typically follows what we call the PEMMDAS rule, P-M-D-A-S. And PEMMDAS stands for parentheses, things like this, exponents, something like 2 squared, 2 squared, oops, I can't type this out, equals 4, things like that. And then multiplication and division. And finally, addition and subtraction. In that order. Okay, so in PEMDAS, in order of operations for basic arithmetic, everything that's inside parentheses goes first. Like, you gotta figure out the parentheses in order. So if there's a set of parentheses and then like add or multiply that by 2, you get the value of what's in the parentheses first as if it were its own equation, and then you multiply the answer to that equation by 2. So I'm going to demonstrate that. So local P equals 2 plus 1. I really need my caret here. 2 plus 1 times 2. Okay, so you could say that this is 2 plus 2, you'd think, because 1 times 2, those are the two numbers closest to each other, but no, we all recognize that due to order of operations, this is done first, and 2 plus 1 is actually 3, so this is actually 6. Now the next one is exponents. Exponents are, and I'm not sure if everybody's covered this, but it's sort of like 2 times 2 equals 4, 2 times 2 times 2, so 3 2's multiplied by each other equals 8, 2 times 2 times 2 times 2, I think I counted that out right, 4 2's multiplied by each other is 16. Now exponent just means you put a number as the base, and then you give it an exponent, which is the number of times that number should be multiplied by itself. Okay, so local E for exponents, let's do 2 to the power of 3. Okay, so 2 to the power of 3 equals 8 because it actually equals 2 times 2 times 2, which equals 8. And I gotta take a sip of water, 1 second. Okay, so 2 times 2 times 2 equals 8. Next up is multiplication and division. So we're going to do M. Now, I'm sure all of you know what multiplication and division are. But MD equals, like here, 2 times 3 plus 2. Or, well, hold on. No, this is better. 3 plus 2 times 3. Okay? And we can also do divided by 3 or something. Here, we're actually going to do it this way. 3 plus 4 divided by 2. Or times 2. And we're just going to make that M. And then we're going to do the same problem down here for division in a second. But okay, you could think this is 3 plus 4 equals 7. 7 times 2 equals 14. That's wrong. 3 plus 4 does equal 7, but that's not what we do first, because due to order of operations and PEMDAS, we do the 4 times 2 first. And yes, this asterisk, this star thing means the x that we usually use for multiplication, but asterisks in math are typically used for the same thing. So 4 times 2 equals 8, plus 3 equals 11. So actually, I'm going to do this up here. 3 times 2 equals 6. And here, it's going to be 3 plus 8 equals 11. Okay? So 3 plus 8 equals 11. Next up is local D, which equals 3 plus 4 divided by 2. Now, you could say, okay, this is 3 plus 4, which is 7, divided by 2, which is 3.5. Technically, you'd be right, but not due to order of operations in PEMDAS. Due to order of operations in PEMDAS, hopefully you already figured this one out for yourself. It's actually 3 plus 2, because 4 divided by 2 is 2. So 3 plus 4 divided by 2, 4 divided by 2 is 2, so 3 plus 2 equals 5. Next up is addition. So A equals, now, addition and subtraction actually go last. So I'm actually not even going to do anything, but I'm just going to do 2 plus 2 equals 4. And then local S equals 2 minus 2, which equals 0. Okay, so addition and subtraction go last. Now, let's also just remember this. All of these also go left from right. So say we have, and I'm going to separate these in order. So parentheses always, 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 always go first. Always. After parentheses, then you do exponents. If exponents are within the parentheses, okay, you do exponents, but that's still technically doing the parentheses. Every time there's parentheses, you actually have to restart PEMDAS within the parentheses and treat whatever's within the parentheses as if it's its own equation, okay? So now we have E, exponents, okay? So 2 to the power of 3 equals 8. And then we have multiplication and division, and these two are done on the same level as each other. So if there's a problem that looks like this, so hold on, I'm going to do local MD equals, let's say we have something that looks like 4 divided by 2 times 3, okay? So this is, you could say, oh, multiplication has to go first. So 2 times 3 is 6, and 4 divided by 6 is 2/3. Wrong. Well, okay, sort of right, but that's not how order of operations works. 4 divided by 2 should go first because multiplication and division are on the same level as each other. And since they are on the same level as each other, you have to do them in left to right order. So the further left something is, the more important it is. So 4 divided by 2 equals 2. And then you multiply that by 3, and that equals 6. Not 2 times 3 and then divide 4 by whatever 2 times 3 is. Now if we had parentheses here, that would change everything because parentheses goes first, okay? Parentheses always goes first. So now, yes, it would be 4 divided by whatever the equation answer to 2 times 3 is, and 2 times 3 is 6, so it would be 4 divided by 6. But that is not the equation we have here. We have 4 divided by 2 times 3. So it's 4 divided by 2 first, and then it's 4 divided by 2 times 3. Down here for addition and subtraction again follow the same rules as multiplication and division. Multiplication and division are on the same level as each other, but you have to go left to right. So if you had a problem in addition and subtraction, it's not really easy to show because addition and subtraction really doesn't matter as much, but just for keeping things simple, if addition, whichever one of addition and subtraction is to the left, you do that part first, and then you do the next part. So if we had local AS equals 8 minus 4 plus 2, you do 8. You could do 4 plus 2 equals 6 and subtract that from 8, that equals 2. Okay, technically you're still getting the same answer, but you're getting to it wrong. Technically what you should do is 8 minus 4 equals 4, and then 4 plus 2 equals 6. So this is technically 4 plus 2. And I don't like the idea of this. Let's make this a bit better looking. So here, we'll do 10 minus 4 plus 2. Okay, so instead of it being 10 minus 6, which equals 4, it's actually 10 minus 4, which is 6, plus 2. So actually, this changes the whole equation completely. Okay, this is why, and I just realized this myself. I'm just now realizing why you have to do left from right for addition and subtraction. Okay, 10 minus 4 plus 2, so 6 plus 2 is completely different than, okay, 10 minus 4 is 6. Add 2 to that, you have 8. But 10 minus 4 plus 2, if you do 4 plus 2 first, and then you have 6, and 10 minus 6 is 4. So there's a difference. So in this equation, you're actually doing 6 plus 2, which equals 8. Okay? Hold on a second, I need to take another sip of water. So there is your order of operations. Parentheses, exponents, multiplication, division, addition, subtraction, addition, subtraction. So multiplication and division are on the same level, and addition and subtraction are on the same level as each other. Okay? PEMDAS. Now, here's the thing that's going to throw pretty much everybody for a loop. In Lua and in basically all programming, there is an extra type of operation, and it's on the same level as multiplication and division. And so I like to pen what I usually call PEMDAS with an extra M. Why? Because it's called the modulus operator. So multiplication and modulus and division. Modulus, which I'm going to do up here as local MOD. Nope, I can't. So I'm just going to do modulus the whole way, is actually using the percent symbol, and it actually really has nothing to do with percentages. I mean, you could argue it does, and in a way it sort of does, but it's not meant to be a percentage of anything. It's actually, if anybody ever remembers this, and maybe you're still at the level of math that does this, and if so, and you're watching this video, kudos to you, because you're going to be a genius someday, and you're going to own the world. But I'm sure all of you remember what a remainder was. When you first started doing division, you would have numbers like 5 divided by 2, and you knew that 2 could go into 5 twice, so you'd have 4, and then you'd still have that 1 left over though, but it would be 2 with a remainder of 1, and you didn't know what to do with that 1 because you hadn't learned about fractions and you hadn't learned about decimal numbers yet, but you knew that that 5 could not completely be divided by 2, and you knew that there was a 1 left over, so you called it the remainder. The modulus is literally just here to help us find the remainder. So I'm going to give a quick example. Let's say we had 5 modulus 2. 5 modulus 2 equals 1. Okay? The modulus operator finds the remainder of a division. Now, if the division works out perfectly, the modulus operator will return 0. However, if the thing doesn't turn out perfectly, such as 5 divided by 2, 5 divided by 2 is always going to have 1 left over. So technically you could say 5 divided by 2 equals 2.5. Yes, that's true. That is perfect math. Congratulations. But we're not talking about actual division here. We're talking about the modulus operator. And the modulus operator divides something basically until it can't divide it anymore. And once it's hit that point, it returns whatever is left over. So in this case, 5 modulus 2 equals 1. If we did something a bit more drastic, and we did something like 29 modulus 3. Okay, we know 30 divided by 3 equals 10. Okay, and we know 27 divided by 3 equals 9. Okay, so that's the closest we're going to get is 27. So the modulus, 29 modulus 3, so 29 divided by 3, find the remainder of that, is going to equal, not 1, but it's going to equal 2, because 27 is the biggest number you can completely fit a multiplication value of factor or whatever of 3 into. A product of 3 into is 27. And then there's still 2 left over after that because 2 is smaller than 3. So the modulus returns the remainder. I'm going to write that down right here. Modulus returns the remainder. Okay? Modulus returns the remainder. Remember that. Modulus returns the remainder. And modulus is on the same level as MD, multiplication and division. So if we had, and I'm going to move this down now to here so that it makes a bit more sense. If we had local MD modulus, okay, and let's say we had 4 divided by 2 times 3, but hold on, let's change that 4. Let's change that 4 to 14 modulus 5. Okay? So you could say that this is going to be 2 times 3 equals 6. 5 divided by 6 is 5/6. And you're going to modulus 14 by 5/6. That's wrong. And actually, I'm going to change this because I don't like this. We're going to switch back to the 4, but we're going to change this to... we're going to change this to 15 modulus 4. Okay, 15 modulus 4. So 4 divided by 2 is still 2. However, you're not multiplying 4 divided by 2. Well, actually, I'm technically wrong. Okay, we're just going to change it to this. 4 divided by 2 is 2, but you're not adding 15 to 4 divided by 2. Okay, you're not adding 2 to 15. You're actually doing 4 divided by 2, and then you're adding 15 modulus 4. Okay, so this is 4 divided by 2 is 2, and you're adding 15 modulus 4. And 15 modulus 4 is actually 3, because we know 12 can be divided by 4, but we know the next highest number is 16. So how much is left over after we subtract 12 from 15? 3. So remember, modulus returns the remainder. The answer is 3. 2 plus 3 equals 5. The modulus returns the remainder, and it's on the same level as multiplication and division. So multiplication, division, and modulus all go together in one big group of PEMMDAS, PEMDAS. And remember, the modulus, the division, and the multiplication go from left to right when you put them in order of each other for importance. That is the modulus operator. Okay, so that's been it for numbers and integers. Remember again, I just want to recap what we learned in this episode. And I gotta take another sip of water because I am talking my voice to death here. Alright, so we learned about the difference between an integer and a double. Integers are whole numbers, and it's a good idea to use integers whenever possible so that you can make your programs what? More efficient. Remember, we also learned that there are three big deals when programming or scripting. The first one is readability. Make sure your code is readable, make sure it's formatted correctly, and make sure that if anybody else looked at that, they'd say, hey, I can understand that. Now, I'm not saying anybody else like your grandma. I'm saying anybody else who knows anything about coding, okay? Now, next up is functionality. And I had to think about that because the word was on the tip of my tongue, but you know, like that feeling when you can't say. Anyway, so functionality. Functionality is the second most important thing. Functionality is what makes your scripts actually work, and it's right behind readability. Like, it's a sliver behind. But if you ask me, readability is more important than functionality. And then third is efficiency, and that is why we use integers instead of doubles whenever possible, because they make our programs more efficient. They make them run faster, they make them run smoother, they make them take up less resources on our players, our clients, our users' computers. Integers better than doubles, if possible. We also then learned about order of operations within Lua, as well as the modulus operator. So let's go over it again. Parentheses always go first. This is PEMDAS with 2 M's. So parentheses go first. After parentheses is exponents, and exponents again are like, okay, here's our base number, and then this is the exponent, okay? So 2 to the power of 3 equals 2 times 2 times 2, because it's the base number multiplied by itself however many times the exponent is listed. So if it was 2 to the power of 1, it would just be 2 times itself never, so it's just 2. But 2 to the power of 2, or also known as 2 squared, equals 2 times 2. And 2 to the power of 3, also known as 2 cubed, is 2 times 2 times 2. And 2 to the power of 4 would be 2 times 2 times 2 times 2. Okay? But 2 to the power of 3, or 2 cubed, equals 8. And we say cubed, by the way, because cubes have 3 dimensions. They have their height and width, and they also have their depth. So if you're looking at like a block in front of you, like one of those little play blocks with letters on them, you know that if you have it facing you, you have how tall it is from the ground to however tall the top is. You have its width, which is the left side to the right side, and then you have its depth, which is the front of it to the back of it. That's the 3 sides to a cube, okay? We'll throw that cube out of our minds now. That's just to get the idea for why it's called cubed. Alright? Next up is multiplication. Multiplication, division, and modulus. MMD in PEMDAS. Multiplication, division, modulus. They all are on the same level as each other, and therefore they will go left to right in importance when you have multiplication, division, and modulus all in the same equation. After that is addition and subtraction, and again, it's going left to right. And as we figured out today, even I figured it out, left to right actually matters quite a lot for subtraction. And I already knew that, I just completely forgot it because it's summer and I haven't started school yet. But anyway, addition and subtraction. Okay? Addition and subtraction are the last 2. Everything goes left from right if it's on the same level as something else. But you have to remember PEMDAS, because that is how math works, especially in computers. Computers are stupid. They will do exactly what you tell them to do and nothing else and nothing more and nothing less. So you have to make sure your order of operations is correct. PEMDAS. Parentheses, exponents, multiplication and modulus and division, addition and subtraction. Okay, I hope you guys learned a little bit today from this, and I know it's still getting a little bit boring, but I promise we're almost out of it. We're almost done with this boring stuff. We're almost to the point where we can make really cool stuff happen. There's only a couple more episodes left of this where you're just learning about how things work, and I'm sure it's not been the most fun, but I promise you it's going to be really, really awesome. Okay, really, really awesome. Now, here's my deal for you guys. I want you to go down into the bottom, and I'm going to come up with an equation here. So I'm going to pause, and then I'm going to come up with an equation, and you're going to see it fill up your screens here in a second. And I want you guys to answer the equation using PEMDAS. Okay, PEMDAS. I want you to use that, and it's going to, remember, PEMDAS with 2 M's, so modulus is involved. In the comments, I want you to comment what the answer to this equation is. And no cheating by putting, actually no. If you can't figure it out, feel free to cheat and just put it into a Lua script and run your game by printing it. Remember, you can print a number just by doing print, and then you can put the number, but you can also put an equation. So if I were to do our parentheses equation, I could do 2 plus 1 times 2, and that would boil itself down to a number, and then it would print 6. Okay? Anyway, so post in the comments below what the answer to the following equation is. I'm going to pause and I'm going to come up with this equation. One moment. Alright, here is the equation. 3 times... Anyway, I'm going to format that a bit better here. Hold on. Okay, there we go. There's the equation, guys. Formatted properly so it's readable. I want you guys to give me the answer. I know the answer to this equation, but do you? That is the question. I will tell you guys in the next episode what the answer to the equation was, and if you got it right, pat yourself on the back. You're a mathematics extraordinaire, and you literally on your way. If you didn't get it right, then please watch this video again and try to figure out where you went wrong. Because trust me, math is one of the most important things, and there's a reason that computer science degrees are so tightly coupled to math that once you've gotten a computer science degree, you're like 2 classes away from getting a math degree as well. So trust me, this episode is arguably going to be one of the most important episodes I will ever make for how to script in Lua. So learn your math, okay kids? Stay in school. Goodbye, have a great day, and remember, post the answer to this equation in the comments, and next episode, I'll let you know what the answer really was. Bye.